Hello, everyone. This is Amir from Audio Science Review. I have another potentially controversial review for you, namely an isolation transformer. This one's from a company called Tripp Lite. It's the IS250. It's their 250 volt amp isolation transformer. I would say it's probably the most common, most popular isolation transformer that people buy. It's a good brand. Here's the one I bought, 130 ratings on Amazon. It costs $140. As you can see, I bought it a few weeks ago or a few months ago at this rate. The reason I bought it was that we were discussing my measurements of and review of other power products, and somebody said, well, how about these isolation transformers? Do they make your audio system sound better? I said, well, I don't think it is, so I'm not going to spend my money on it. But if somebody else wants to spend their money, I'll go ahead and test it. And indeed, somebody was kind enough to do that. So I went ahead and purchased it, and only now getting around to testing it. As the name indicates, there's a transformer inside. This is the box itself. Let me get it. It's quite heavy. Despite being small, it's quite heavy. And you can see it's got a nice on-off switch in the front. And in the back, has two outlets and a standard thick IC, IC at one end cable. It's down before my arm breaks. A strong preface. I posted this review last night, and the classic misunderstandings happened. My goal in testing products like this is to see if the audio fidelity is improved, meaning the classical thing people say, they buy one of these things, power cables, conditioner, what have you, and they say the background got blacker, the sound stage got bigger, or the highs become smoother, sound became more analog-like. That's what I'm addressing in here. I'm not addressing the case where somebody has had some hum and buzz or whatever and got one of these and it happened to fix that issue. If you have hum and buzz, post on a forum, we'll walk you through and people will give you correct advice on what to look for. And the best defense against that, as I've said before, is balanced interconnects. But if you've made a mistake of using RCA, then, there are issues to be resolved. But stepping back, why these products have such high appeal, to audiophiles, is because the name isolation. People automatically think there's a moat in there that keeps all the bad stuff in AC out of the your audio product, and all the great stuff comes out the other side. And on paper, that seems to be true in that inside of transformers, there's two coils, just windings of wire, and an iron core, and that magnetically sends a signal from this side to the other side. In this case, the signal is 60 hertz and mains input. Because it's AC, it sort of jumps and it goes from electrical to magnetic back to electrical on the other side. The turn ratio is 1-to-1, meaning what you put in is what you get. So you get 120 in, you get 120 out, or 240 in, you get 240 out. And if the input goes up and down, the output goes up and down with it. So right away, this is not what you think, which is, oh, there's this rock solid thing in here, and the one on the left side doesn't do anything. And specifically, and I'll show you, if any kind of noise is AC, it will also transmit subject to any filtering that may exist in the device. Now, if you go read the Amazon reviews, you immediately notice a major issue with this, and that is the fact that if you, let me get this guy back again. You'll see that this has a 3-pin outlet, 3-pin plug, and it's got a grounding, safety ground pin in here. And it has the same thing in here. Is a 3-pin connection, it's not 2-pin. And I won't bother showing you, but if you put a meter across this pin and the safety ground in here, they're both connected together. So if they're connected together, there's no isolation, right? Anything that goes on that safety ground travels right through to the other side. And the safety ground in your meter, in your panel for your house, at least in the US, is connected right to the neutral as well. So while there's some isolation in here in there, but the main thing people buy it for, it doesn't do that. It is not isolated. It carries the safety ground from input to output. So if you have a ground loop that's caused by that, and You plug this in, it will not make any difference. If anything, it adds more length and could potentially cause noise problems that you didn't have before. And so that's mistake number one. Now, people immediately tell you how to hack these devices and remove that. So there is an application for that where that's kind of valid, but you got to be very careful in that. If you have you're doing repairing repairing electronics on a workbench, and your instrumentation is ground reference, like the oscilloscope I have, the shield in it is actually connected to the same safety ground. If you connect that to a hot signal on the device that you're testing, you get a short and really bad things happen. So in that application, you do want true isolation. So people open these boxes and disconnect that connection that goes from input to output. The moment you do that, first you violate this UL certification, which is a safety certification, because now if one of these hot wires comes loose and connects and touches the chassis of this metal device, the chassis can get hot and your circuit breaker will not pop, which means you touch this thing, you could get nasty shock or get electrocuted. So right away, you violated the safety protocol of this device. Furthermore, your target device, if it's a 3-pin device that connected to this, its chassis is no longer got any safety ground protection either, because you disconnected that. This pin will no longer be connected to anything. So if some hot wire gets disconnected inside there and connects to the chassis, then again, you create a shock hazard, and you're basically defeating decades of proper conduct and code that says why this pin is there. Now, if you have a 2-pin double insulated device, that won't happen, but that's much more rare in audio than the 3-pin variety. Now, in the context of doing a repair in the hands of a technician or engineer that knows what he's doing, and he's only doing this for a few hours or repairing something, it's accepted practice, and it's necessary most of the time, because you got a device that is ground is at high potential. How else you going to work on it? So in that limited use scenario where you're in control, you're somebody with knowledge of electricity working on stuff, it's fine. In just a few hours, you're going to repair something and put it away. Whereas if you're going to hook something up, leave it in your stereo, that's a completely different animal, where you're going to go in, day out that way, and things could deteriorate, and they can be, just luck of a draw that, something bad could happen in the one unit that you have that doesn't have proper safety protection. So in no way, should you go in there and do the hack that people are talking about. Most of those people are, again, correctly talking about it and using it for technician use for repairing things. But please do not go take this device, remove the hack, say, okay, now I made it totally isolated. Now I'll show you in a minute why that won't help you anyway as far as your fidelity. But know that this is a misnomer in there by the company Tripp Lite. Even though I like their products, I think this is well-built device. I use their power strips and so forth. I just think it's just improper to not emphasize that this is, true. It's not isolated. I mean, it's what goes on the input on this ground pin, on this side comes out here. So there's no true isolation of the 3 pins is presented on this thing. So that's the key thing in here. I want to make sure nobody misunderstands it. Now, our purpose in here, as I said, isn't to investigate electrical devices for the sake of electrical device analysis. We're not called electrical science review, we're called audio science review. My goal is to figure out, do these things improve the sound? Because a lot of people read that an isolation transformer is something that sounds good to them, as I said, and plug it in, and they report improvements on these things. So they report improvements on a lot of things. So as usual, I start by measuring my incoming AC, with my high voltage differential probe, which means that it doesn't pick up noise on its own, and measure my AC. And my AC is as dirty as ever. This number, I think, goes up and down some percentage point. But basically, this is 60 hertz coming in, and then these are all the unwanted things, if you will, all these distortions and noise, and that's just normal. So if you were to treat this as an audio device, it has a sign out of 31 dB on this thing. It's 60 hertz, you can see, and again, this voltage you have to multiply by 100 to get the true voltage, so it's 123.7 volts. Okay. Now let's measure what happens if I take that exact same power and running it through the Tripp Lite isolation transformer. We have positive right away in that this noise floor starts to get much slower at higher frequencies. Look at the slope in here. Now let me go back. You can see there's gentle over here. So there's definitely high frequency filtering can happen. And that's the nature of the thing. You got big inductor in there, and you've got capacitance in there, and you have coupling inefficiencies, and it all actually helps to reduce high frequencies. But here's the kick here. If you have a linear linear power supply in your audio equipment, it's doing the same thing. So all this time people think, oh, wow, I got all this noise, I got a filter. No, that transformer inside your equipment is already doing that filtering. And there's tons more filtering in your audio equipment, as I've explained before. But importantly, all these nastiness, that's much higher amplitude over here, they have not changed. So as a result, our sinat hasn't changed, and voltage has, I think, 1.26. No, that's just normal variation. But there are some losses which I didn't measure, because you got a transformer in the middle, and those windings have resistances, and you will lose some power. So don't plug in high power equipment. This one's too small anyway for me to have hooked up any power equipment. So, but importantly, look at how, we have deformation of the AC sine wave over here on the tips here, and we had the same deformation before. So nothing got magically better. All the junk that was in the original signal, if you will, the AC power, ran right through the thing, as I explained. So other than some high frequency filtering, nothing happened there on this thing. So I went ahead and did a high bandwidth test. This test only goes to 22 kilohertz audible band, but some people make arguments about higher frequencies. So let's go and test it up to 90 kilohertz. And here we clearly see the effect of the filtering that it provides, or I should say inversely, lack of bandwidth on this thing. You can see that it lowered the noise floor here of AC by this amount. But here, in this middle, it actually made things a little bit worse. You can't tell over here, but these spikes are actually taller than raw AC. The reason for that is that this is a nonlinear device. That magnetic field is not a perfect magnetic field. It saturates and unsaturates. And so it actually adds its own distortions to the signal. So it actually makes things worse in where your hearing is most sensitive, ironically, but improves the higher frequencies on this thing. But key thing, as always, the reminder is that those are AC measurements. We don't listen to AC, we listen to audio devices. So all that stuff is smoke and mirrors. The name of the game is the sound of my audio system improved? So I could pick 100 different pieces of audio equipment and test. That obviously is not practical, but I just grabbed the Topping A90 that's on my desk all the time that I use for headphone testing, and first fed it just from AC mains and just did a quick setup for it, and we can see that its noise is minus 140 decibel. I mean, its distortion is minus 140 decimal. And when you add noise and distortion together, it's at minus 120. And that's 5 dB better than your best case threshold of hearing. So this device, just plugged into the dirty mains, has no need to anything to be cleaned up. It's not in its own cleaning internal. On this thing. But an interesting thing happened. I was getting ready after I ran this test. I just turned on the Tripp Lite before connecting anything to it. So it's just Tripp Lite just plugged into the AC, but Topping A90 is still hooked up to my wall. As soon as I turned it on, and it was sitting where it's sitting now on top of, analyzer, and, I've got a rack in here, it's metal, and the cables were all XLR shielded. Look at the hum that it induced right away. This is a hunking big transformer generating massive magnetic field, and that magnetic field is like a halo that's leaking into everything around it. And indeed, it managed to corrupt my measurements and induce, this mains hum at 60 hertz. Now it's at minus 130 dB, still well below audibility, but know that there's damage done in here. Objectively, our system got worse the moment we turned this on. Now, so if you're going to use it, set it way the heck away from stuff on this thing, and because it is a big transformer that's in there, and this is a low power device. You can get bigger ones, but we have bigger magnetic fields that they create. So right away we see that it can cause problems, and indeed when I route things through it, Now, this time it is powering the topping A90. Sorry. We see that the mains leakage is in here, and it shows up just as if, we hadn't plugged anything into it. But outside of that, nothing's changed, right? Our output of our DAC is the same. Our amplifier preamp is the same. Noise and distortion is still dominated by the inherent noise of the device. So it didn't change. This device is just as transparent as it was before this tweak, and certainly after this tweak is just as well. Now, a common criticism people get is that, whoa, that's at one frequency, how about at all other frequencies? Maybe it's doing something else. Well, the standard test I run has where I test the noise and distortion at every frequency not every frequency, but step through it, from 20 kilohertz down to 20 hertz, but the capture bandwidth is 90 kilohertz. That way we can capture harmonics of 20 kilohertz, which would be at 40, 60, 80. So we capture that many of them, and we capture all of that noise spectrum above audible band. But we can see that the two graphs, the red and the blue, land right on top of each other. There is no difference at all, other than a little glitch in here, just a run-to-run variation. So at no frequency is there any improvement. Some I don't usually bother responding to, but people keep latching on to this timing analysis. What happened in timing domain? There maybe some good happens in timing domain. First of all, this thing is a transformer, it's a low-pass filter, so it actually doesn't like high-speed signals, doesn't like sharp transients, because those have a lot of high-frequency content. When you filter out the highs, the device becomes slow. So this is a slow device. So if you think something good is going to happen because it improves transients, it can't do that because its nature is to slow those down. But anyway, I ran an impulse test, and you can see it with the raw AC, and you can see it with the going through the isolation transformer. Indeed, if I plot them both together inside the software, the two graphs land on top of each other. You can't see one from the other. Now, one of the reasons I don't run these tests is that a lot of caveats go in there. You might say, well, what are all these ringing over here? I thought you said it was an impulse, should be just a stick. Well, no, if it's just a spike, means you have to have infinite bandwidth. This test has that audible bandwidth, 20 kilohertz. And when you filter everything above 20 kilohertz, physics tells you, nature tells you that you cannot have an impulse response that has infinite bandwidth. 20 kilohertz is way below infinite bandwidth. So you get ringing, pre and post ringing. But this is just the way the signal processing of this measurement works. But regardless of what measurement does, there was no impact one way or the other. We still have a sharp focus of a sharp spike in here, that how long it took to settle down or go up, identical in both cases. So there was nothing that this device did in a timing domain that made a difference whatsoever on this thing. Now, I should say that my focus isn't to measure electrical performance of these things. I give it the benefit of doubt that it does everything it says. And one of the things it should do is that if some kind of noise source goes on the hot and neutral of your wires, and it's exactly the same, that means that between the two pins the difference would be 0, then that won't by definition be able to get to the other side. So if you have something that induces identical noise to both pins, it will isolate and block that. And there may be scenarios where that could be helpful, or by chance and luck, you may eliminate some noise and things. So my focus isn't to say that it doesn't do that. I'm saying actually the opposite. Let's say it does do that. But just remember that this device doesn't provide isolation for your safety ground, which is what is used in RCA connections between two devices. That RCA outside shell is connected to the chassis just the same, usually, unless you got a double insulated device. But even then, it's probably hooked up that way. But anyway, that isolation that people think, oh, I'm blocking the noise from ground, isn't provided by this. And if you hack it, you have an unsafe device, unsafe situation. And for what benefit? There is no benefit. There's no measurable benefit, and I can tell you, there's just absolutely not a hair has changed, other than for the worst, with some mains inducement in this. But, you look at the full spectrum of what's happening in audio. This is not just one number or a sign ad I'm showing you. I'm showing you full Fourier transform that has every little tick in here, has every bit of your spectrum of noise and distortion, all encapsulated in what's happening in your audible band. And nothing has changed. And again, we do the same thing with wide bandwidth, and nothing has changed. So all of this always points to the same reason why these devices don't even begin to make a difference is because, as I've explained before, the first thing your audio devices do is convert AC to DC, and conversion of a sine wave to a flat line requires all aspects of that sine wave to be thrown out. So of course we throw out the 60 hertz, we throw out the harmonics, we throw out the noise, because we filter all that stuff. It's the first thing you learn to do. I think I built my first power supply when I was, I don't know, 7 or 8 years old. I learned from my older brother that was into electronics and built a little linear regulated power supply. So, and what you do is you put regulators in there and you put filters in there, filter capacitors, and the transformer does some filtering, as I mentioned. So this is the most basics. And if you're buying some kind of high-end audio equipment, that better have like 14 stages of filtering. If you paid lots of money for a high-end system, it comes with tons of over-design built into them usually, unless there's some voodoo product you buy. So that's the last place you want to second-guess your designer and say, oh, whoa, as smart as he was in building this $50,000 amplifier for me, he didn't know how to get rid of noise coming in from AC. I'm going to go stick something like this in front of it. So as I've shown you, it just makes no sense. There's no logic to this thing of why these work, other than delay intuition. We think of them as like filtering dirty water and getting clean water at the other end. Those analogies don't work. If they worked, manufacturers would be the first to show you measurements like this and saying, oh, look, your amplifier is 5 times more quiet now because of this. They could sell tons more product if they had objective proof. To their credit, Tripp, Lite, while they take some liberties with their claims, and this is isolated, it's great for surges, great for this and that. They're not selling it to audiophiles as an audiophile product, and the fact that people go buy them is mostly their fault. In that they're taking their lay intuition of isolation, thinking that means literally a moat, as I explained. So this is not something damning about the Tripp Lite as a company or this product in the specific. If you know how to use them, you know how to modify them, it's got applications, but not for fidelity improvement, which was the motivation for this review, where a member asked, well, do these things improve sound fidelity? And so we've shown that the likelihood of them providing any fidelity improvement is so small, because if it was going to do anything, it would have done something here. We should have reduced this distortion or noise for something it should have done, but it just doesn't do that. So please don't go spend money on this stuff. These things waste power. It's another thing that could go bad. It just, and definitely do not modify them if you don't know what you're doing. You're dealing with mains and safety issues. Okay, I hope you got something out of this video. I'll see you in a future one. Bye-bye.